What do you mean A? But how do I know what A and B are? I don't. I can't just multiply these. I haven't proven they're independent. So now I need to check, are these events independent or not? Let's find out. So if the events were independent, then, well, if the events were independent, then the probability of engine trouble and transmission trouble would be the probability of engine trouble times the probability of transmission.
Wait, it's true. Wouldn't it be better to do the first justification of probability of A over B equals probability of A?
We can do that.
Just because like it doesn't give us the
So what Alex is saying is, why don't we try to verify like this? The probability of engine trouble given transmission trouble must equal probability of engine trouble and transmission trouble divided by probability of transmission trouble. We're still slightly in a bind though. We're still in a bind here. We don't know this. We're still in a bind. We have a slight problem here.
Can't we just find it?
This is how you need to problem solve. So let's actually problem solve. This will be exciting. So, this is not going to help us. What will help us is the following. I know this. I am purposely taking this very slowly and being complicated because this is what will happen on the exam. This must be true. This is always true for every two events. Always true. This is a rule for any two events. We know this is 0.405. We know this is 0.405. You must stop me with questions. We know this is 0.3. We know this is 0.15. We have no idea what this is. Let's call it X.
We can solve it, just solve. We can solve it.
Karina? In order to check whether it's independent or not. So just give me 2 minutes and then it'll become clear.
Oh, yeah.
So now this says 0.405 is equal to 0.45 minus X. So add X to both sides, minus this over here. Some very baby algebra right now. So X is 0.045. So what I just found out is, and X was the probability of both happening. So the probability of both is 0.045. The probability of both engine and transmission problems is 0.045. And now I'm done, because now I just do one final step. The probability of engine trouble and transmission trouble is equal to the probability of engine trouble times probability of transmission trouble if the events are independent. This is a rule for independent that we just talked about. And just verify the rule is true. This we just found is 0.045. Probability of engine trouble is 0.3. Probability of transmission trouble is 0.15. Do these equal each other? Yes, they do. 0.045 equals 0.045. Check it off. These two events are independent. Which is interesting in the real world. They don't think they actually are. These two events are independent. Graham?
Couldn't you just solve for x?
Hmm?
Couldn't you just solve for x?
I did solve for x.
I know, but like just without doing all that equation, couldn't you just like plug it into the probability of v and t?
Say that again?
Couldn't you just plug it into the probability of v and t, like just that by itself?
But I don't know what the probability, but I don't know what this is. I gotta find it.
That's why. But it's just multiplying it.
But this only works if they're independent.
That's why.
But I need to check. So if I had just multiplied these to begin with, I would have gotten 0.045.
Yes.
So that's the same thing. Yeah. So that's fine. So there are just two different ways
That's
to
what
solve the
I'm
problem.
asking.
Yeah,
That
it's two different ways. Two different ways to solve the problem. Two different ways to solve the problem. Questions?
So they are independent.
So these two events are independent. All right, let's continue forward.
It's not like big check. Making it so complicated.
All right, let's look at this one. So here, they're asking us the following question. Is title independent of gender? Is title independent of gender? So, is title independent of gender, or does title depend on gender? Last unit, we had problems like this, and we solved them using the following technique. Just so a brief review, we solved them using the segmented bar graph. Remember we had title here, here we had percent,
Oh yeah.
and we said, okay, we said, well, if we want to find, let's start with management. Within management, 7 out of the 13 are male. So that means that within management, 54% are male. You guys will remember the segmented bar graphs?
Yeah, I do. But,
Female.
Is this the way you're gonna keep solving them?
No, I want to show you another way. 6 over 13. So for female, we have 46%. And then for supervisor, we have 8 out of 20 are men. So this is 40%. 40% male. 60% female. And finally in production, $45 out of 117, so only 38% male. And the rest, 62 female. 62% female. Now, clearly, title and gender are associated. Here, there are many more males who are managers than in production. So, there are being a manager, or being a supervisor, or being in production is different based on your gender. It's not like it's just randomly set up. There is some association there. There is some dependence there.
So no.
So the answer to this is no. These are not independent. Now that's one way to do it. There is a simpler way with probability to do this. So this is one way. Will be to check the segmented bar graph. Now, with probability, I would just want to check the following situation. Is the probability of A given B equal to the probability of A? That's one check for independence. The other check is the probability of A and B equal to the probability of A times the probability of B. If both of those are not true, the events aren't independent. That's it.